So we have with us today Dr. Ray Gallant, Vice President of Sustainability and Productivity Services with Volvo Construction Equipment. Actually, Ray and I have been working together for many years now. We actually tested out some of Volvo's electric construction equipment early on. So excited to be on to have Dr. Ray on the panel with us today. We also have Kevin Davis, Senior Director of Residential and Commercial Policy and Specifications with CarbonCure Technologies, a company based out of Canada, as well as Michael Fletcher, Vice President of Sales with AiCrete. Thank you so much for joining us today. I'm very excited about this panel. Definitely what I focus on in my day job. So let's start with introductions. So maybe all of you can give a brief introduction about yourself and how your roles are contributing to technological advancements in your respective industries and the company that you specifically work with. So we'll start with Dr. Ray Gallant.
Okay, good afternoon. Dr. Ray Gallant. I'm with Volvo Construction Equipment. So we manufacture obviously a full line of heavy equipment products, so are working furiously to try to get the emissions down to get a more sustainable, more carbon-friendly footprint across all our equipment types. And if you think of the breadth of equipment and applications out there, that's quite a daunting challenge. It's not as easy as changing one or two models, and it's not simply changing to a battery electric drive, for instance, that's going to be the solution for all applications. So we quickly run into the limitations of different technologies, which is something we'll be discussing in this panel. So excited to be here. I've got about 30 years in the industry, engineering background. So this is a subject near and dear to my heart. We recently split my product management job into two roles. One takes care of the traditional internal combustion technologies, and one takes care of the new technologies in sustainable power that we see coming up. So I took the new technologies role as part of my umbrella. So thank you.
Thank you for joining us today, Dr. Ray. Michael?
Sure, yeah. Michael Fletcher, I'm the VP of Sales and Marketing at AiCrete. Joined AiCrete in 2022. It's a Bay Area startup. Joined them shortly after their seed round. I've got a background primarily in concrete and construction, going back about 24 years. Worked for cement companies as well as concrete admixture companies, and then had a brief stint in construction chemicals and selling engineering services as well. AiCrete's mission is essentially to increase the profitability of customers via our software platform, AiCrete OS. Essentially, we're using artificial intelligence to drive mix design optimization to increase profitability, sustainability of the concrete products, and also drive efficiency and productivity within our customers' operations. So,
okay, thank you, and thank you for joining us. Kevin?
Hey, good morning or good afternoon, everyone, depending on where you are. So as mentioned, I'm with a company called CarbonCure Technologies. We're actually based out of Halifax in Nova Scotia, started in about 2012. So we're just sort of post-startup phase, so a little further down the path than Mike and his organization. We're really focused on carbon removal technology for concrete production. So we have a system that's a retrofit technology. That one of the reasons we've had such strong adoption is we can really bolt it onto any ready-mix plant. So substantial number of locations in North America and expanding into the international market. Our global mission, if you will, is to annually reduce and remove 500 million metric tons of CO2 by 2030. In terms of where we are on that journey right now, we're somewhere a little north of 250,000 tons. So we're working through that process. Backed by some pretty interesting names through Breakthrough Energy Ventures, people such as Amazon, Microsoft, and others, and rapidly evolving in the North American market. And I've done a little bit of work with my fellow panelist, Michael, on this. So I think we're all on the same page here. Look forward to participating this morning.
Okay, thank you, Kevin, and thank you for joining us. So we'll start with our first question, and Kevin, maybe we'll start with you. You talked a little bit about what the CarbonCure technology is. Could you go into more detail describing the technology and how it reduces emissions and supports reduction in embodied carbon in infrastructure projects?
Yeah, for sure. So when we look at reducing CO2 in concrete, the primary contributor to the carbon footprint of concrete is cement. And so depending on whose numbers you read, somewhere in the order of 8 or 9% of global CO2 emissions come from cement. So we have a technology that actually engages with the cement through the use of CO2. So we take waste byproduct CO2 that's captured from petrochemical facilities, things of that nature. So it's a waste byproduct that typically is used in the food and beverage industry. We've just found an industrial application that chemically reacts with the unhydrated Portland cement when you mix it with ready-mix concrete. What that gives you is it gives you the incremental strength benefit that allows you now to optimize the mix design, and AiCrete does some of this as well, but we can take somewhere in the order of about 25 pounds of cement out of an average mix design. So when you take that over tens or hundreds of thousands of yards of concrete, it becomes a substantial contributor. So there's two parts of it: is we're sequestering that CO2 that we use. It's not re-released back into the atmosphere. It's permanently sequestered, which is part of the attraction in our technology. But you get the secondary benefit of reducing the carbon emissions through the reduction of cement.
Mm-hmm. Okay, and then you mentioned AiCrete. So Michael, maybe we'll turn to you. So you could describe how AiCrete and the technology that you're using is also supporting embodied carbon reduction.
Sure. So we take a different approach. We're leveraging artificial intelligence to actually do mix optimization, which traditionally is a very cumbersome kind of trial and error effort done by concrete producers or engineers. If you think about, when you optimize concrete in a traditional method, it's change one thing and cause an effect and see what happens. And essentially, there's a point of diminishing returns where, we like to say producers want to get it within the goalposts of good enough as far as performance and all the criteria they're trying to achieve. And there's just always something left. What AI can do essentially is something called multi-arm banditing, where it can run, tens of thousands of combinations of a producer's materials to ultimately generate new designs. So essentially, it breaks their rules of thumb. Any kind of baggage they maybe have. If you think about the material palette today, none of the materials we're using are the materials that we used even 5 or 10 years ago. We've got reclaimed fly ash, we've got limestone cements, we've got new generation of admixtures. So to think that you could do it the way you were before, you're leaving things on the table. So our typical performance, we're reducing costs by dollars, not cents, for our producers. And our carbon reduction is on the order of about 43 pounds per cubic yard by doing that optimization. And the other difference, there's multiple AI approaches out there, which is great for the industry. Our solution is kind of tailor-made to the producer's palette of materials. So we actually characterize on a chemical basis their cements, their aggregates, their admixtures, et cetera. And do tailor-made AI on their actual palette.
Mm-hmm. Okay, very interesting. And Ray, you play in a little bit of a different space. So that's embodied carbon as it relates to emissions associated with materials. But you're in the equipment space. So how is it? What are some of the different technologies that Volvo is working on to reduce emissions on a construction site?
Yeah. So we. First of all, if you look at heavy equipment, like I said, there's a large variety of equipment applications that are out there. But basically, if you focus on the carbon emissions or the carbons that are in the emissions for equipment, about 90% of it on a 45-ton rock truck, for instance, about 94% of the emissions are purely from burning fuel. From during its lifetime, they're burning the fuel. Only 6% is in the building the machines, the power it takes to manufacture them, disposal, all those other factors that we calculate into the carbon calculations are still only 6%. So in our business, if you want to make a meaningful difference, you really have to tackle that burning of fossil fuels over the life of the machine and look at it through that lens. So we see 3 technologies as really providing a solution set for this. So the the technologies around sustainable power. We used to call this e-mobility. We've now gone to the term sustainable power because that includes more than just battery electric drive or electric drives. It's all the technologies that can come in and replace basically fossil fuels as an energy source with some other alternative. The second set of technologies that's equally important, if not more important, is the digitization and AI technologies. And the third one is the automation technologies. And the reason for that is because if you want to reduce the fuel burn on the site, you can spend millions and millions of dollars trying to get the machines to be more efficient and more productive and get a % or two increase or gains on it. Or you can spend some of that time and money looking at the site and the overall waste in the site processes and the coordination between machines to make sure you don't have machines idling or waiting for other processes to finish, and make your sites more efficient that way. And we really see it's the combination of these technologies going forward and the ability to control and drive efficiencies and productivities in the overall site that'll make the big difference going forward. So we obviously have individual solutions, how to run a battery electric machine, how to do a hydrogen drive, hydrogen fuel cells for power. We have all those technologies available, but really the key is how do you make the overall site more productive, more efficient, more communicative with the machines and the operators on the site to make it a better, more efficient site from a sustainability point of view.
Mm-hmm. Yeah, thank you. And, we've talked about the different technologies, but, I'm interested in hearing more about where some of these technologies have been deployed. I mean, from our perspective at Aecon, we are seeing a lot more requests in the last couple of years from our clients to use concrete with lower emissions, or use zero emission vehicles or electric equipment on site. So, we're seeing that we're starting to deploy some of these technologies across projects, but want to get your thoughts on or your insights on some of the places where these technologies have been deployed, examples of projects, and what has the reception been like, and what do project teams have to do differently to deploy these technologies? And maybe Kevin, we'll start with you again.
Yeah, great question. I think, primarily a lot of our original adoption has been in North America, as you would imagine, with a North American-based company. And so we've, deployed our technology in, some 600 plants or so in North America. We're starting to expand into the international markets. The European market is very advanced from a sustainability standpoint. So countries like Germany and France and the UK are a little farther down the path than some others. We're seeing some expansion into the Asian market as well. So a country like Singapore is pretty progressive in terms of sustainability, as well as very advanced from some construction methods. So this is becoming much more of a global sort of adoption, if you will. The types of projects that we work on are everything from basic residential stuff. So we're doing slabs and driveways and gutters and sidewalks and those types of things that are not particularly exotic. Tremendous amounts of warehousing. So, Amazon is an example. I can't count the number of facilities that we've done for Amazon as an example. Some of the Microsoft campuses. Big tech seems to really like our technology. Some of it is the adoption and advancement of some of the things that we're doing, and there's certainly a software component to our business as well in terms of trying to track those productions. There's actually a cellular chip that's in our system that tracks every single time we happen to dose the CO2 into a mixed design. So pretty broad range of projects. We did the Amazon HQ2 in the on the East Coast. So everything from warehouses to office buildings to homes. So, what's really nice now is that the technology has become somewhat ubiquitous in terms of a concrete submission of an engineer taking a look at this mixed design and going, hey, what's this mineralized CO2 stuff? It's not so new to them anymore, and they're much more willing to adopt. We spend a lot of time focusing on, and Michael probably has this experience as well, and we use the term sort of prescription versus performance. And many of the mixed designs in the concrete industry has been very prescriptive. There typically has been a lot of resistance to change because of the durability requirements and just the risk and liability on projects. We've started to push that envelope where, our solution and some others are becoming much more accepted by the design and engineering community.
Thank you for that. And you've done some road projects and airport work as well. Do you have some examples of that in the US and Canada?
Yes, we have. So certainly one of the bigger kind of airport projects actually was in Calgary, Alberta. So we did a good number of runways and runoff areas. Kansas City, Portland, Indianapolis are other examples of locations. So, fortunately, the airport infrastructure is expanding. Those are good opportunities for concrete as a durable and a sustainable material. So those types of things. Lots of work with departments of transportation right now. It's been a real focus of our regulatory working group to make sure we have the various approvals required by the departments of transportation. And I'm working on one of the first ones we did was actually in Hawaii. So not the roughest of environments, but we actually did some work with the Hawaii DOT to be able to test out the performance of our material.
Yeah, the Hawaii example was the one that I was thinking of, and I remember reading about it.
Everyone always goes there first. So.
And Michael, turning to you, so being a software company, could you provide examples of how companies have leveraged the software and examples of projects? And then I think focusing more on also what project teams would have to do differently to be able to deploy your technology.
Sure. So it's kind of an interesting journey. We're kind of behind, just from a timeline perspective, kind of CarbonCure's journey, right? As far as, we started in commercializing in 2022 and doing proof of concepts just to show people that the AI worked. And most of that work was done primarily with the buyer, the ready mix producer. So once we established enough data to show that that it worked, it's actually when we converted into the software. Where we used to do everything in our laboratory, we now have producers using the software throughout the country to do this optimization themselves, supported by us on some of that material characterization. And those producers could be anything from single plant operators to multinationals and everything in between. And it's really just been more about getting that baseline adoption. Whereas, as we evolve, from my former life, I do speak a lot to engineers and specifiers as far as, how can we now deploy this on our project? So similar to how Kevin was describing, he's in a lot of driveways and sidewalks, and that's where we are too. I don't necessarily know where every yard of my concrete goes or my customer's concrete ends up, unless an engineer comes to me or an owner and says, hey, we'd like to see how to leverage this technology. And then it's a matter of, how do you coordinate that with the producers and, make sure that we have a large enough footprint to support that. From doing things differently, the producers generally, other than, kind of tweaking their own processes internally, because we do have a quality control software that can actually replace what they use today, but it's just got more tricks under the hood as far as AI. There's not a lot of change on their end other than throwing out all their rules of thumb and baggage from before. But from a project standpoint, it's been interesting, the conversations we've had early on with some of the major engineering and construction firms around how do you integrate it into the process without slowing things down and making things cost more. It really, I think it's about having it be on the front end part of the conversation, and kind of divvying up the wins, right? Because we're reducing costs and we're reducing carbon, being thoughtful about who gets what and who wants what, right? What the end goals are for the project team. But it can be as simple as specifying a reduction of X or Y on carbon. It can be something that's done after the bidding process. It can be something that's put in the bid documents early on. So kind of varies.
Okay, thank you, Michael. And turning to you now, Ray. So from your perspective, focus on sustainable power and low carbon construction equipment. Could you give examples of where some of these technologies have been deployed? And then also that same question of what do employees on site, what would they have to do differently if they are using electric mini excavator, or if there's use of sustainable power on site? What do these employees have to do differently?
Yeah, so first of all, there's different solutions depending on the application and type of machine. So we've seen a lot of companies go to alternate fuels as a baseline, which is a step towards sustainability. It's not a zero emission fuel, but it certainly is better than a pure fossil fuel burn. So, biofuel additives, synthetic diesels, HVOs are all examples of that. So we've seen a lot of companies moving towards those fuels if they're available in their area and if the price is reasonable for them. And then if you get the zero emission solutions, the battery electric is what comes to mind. So the first few machines you've seen out on the market for most manufacturers has been a small battery electric machine. And the limitation, of course, there is how long does the battery last for your duty cycle, and how fast can you recharge it, and how much power can you really get out of the battery. And as you move up into the larger equipment and longer duty cycles, putting in a battery heavy enough and with enough power to do that duty cycle becomes almost impossible or very prohibitively expensive. So then you turn to other technologies like grid connected machines. So where you basically have a stationary or relatively stationary machine and you plug it into the grid and draw your power directly from the grid and to operate that machine. Or you could go to a hybrid solution, which again, you could have a hydrogen fuel cell hybrid, you could have a diesel hybrid, you could have a number of different possibilities there. Or you could go to a hydrogen solution, which could be either fuel cell directly to generate electricity or burning hydrogen in your combustion engine to give you the power. So the number of different solutions. What they do have in common is because they're electric drives, generally what you'll find is there's far less vibration, a lot less noise, no emissions, obviously. And what we're hearing from the operators is performance is great on them. A lot of operators will swear the machines are more powerful. They're actually not. From an engineering spec point of view, they're the same design specs. What they're feeling is that electrics are much more reactive than a traditional diesel drive. So when they pull back on the joystick on an excavator, it's full power immediately and the machine is moving and doing what you've asked it to do. So it feels to the operator as more powerful. But at the end of the day, they get off, they don't have the smell of diesel emissions, they don't have the vibration, they don't, aren't walking like they just got off a boat for the next hour the way they would on a traditional machine. So it's a much more comfortable operation for them. So generally the response from the operators, from the people who've seen it, is very, very good from a performance point of view. The concern comes with recharging and duty cycles. So the same range anxiety that you have in EVs, you have in heavy equipment. If they have an 8-hour duty cycle, they're nervous about the fact that, is my battery going to hold up? I have a really tough application today. What's the battery life? Because of course, the battery depends on the power you're drawing for your particular job. So that's been one of the education processes that we've had to go through, is various different charging sources and how we can opportunity charge for battery electric, or even refill more often for hydrogen, because the volume of hydrogen you need to run a hydrogen machine is much more than the equivalent volume of diesel. So all those things come into account, and that's really where we've had the pushback. The performance, the acceptance of it as a machine is great. It's been very, very positive. Mm-hmm. So in summary, the machine is the easy part. It's everything that goes around it that's more difficult, and changing the habits and the expectations of the people on their job sites is more difficult, which is understandable considering we've had 100 years to develop a diesel infrastructure and only really 10 years to develop an electric, or no time to develop hydrogen infrastructure to run these machines off of. So,
and we have, in terms of like deploying where some of these technologies have been deployed. We actually have a question, so I'm going to ask it now because it's relevant to our conversation. Are there any cities around the world requiring electric construction equipment through local bylaws?
We're starting to see that, but most cities right now are reluctant to do that, to require it, because of the fact that very few manufacturers are out with a full line, or that they can do their whole job with it. Volvo is one of the few that can do certain jobs, and we can't even cover all the jobs, obviously, not yet. So as a regulation, as a demand, no, but cities are very much in the frame of mind where they're saying, okay, I want at least 25% of the machines on this job to be zero emission. That's quite common right now.
Yeah.
About the most strict I've seen is basically London in the UK, where they actually will have certain jobs that they will require 100% electric. It's not a regulation yet, it's just in the job specs when you bid it or when you put machines on the job.
Mm-hmm. Yeah, thank you for that, Ray. And Thomas, thank you for your question. Another really good example is Oslo, Norway. They have strict regulations in terms of the emissions from construction projects in the municipality. And I think they were one of the first municipalities also to have a road project that used zero emission equipment. So that's another example. Thank you, Ray. So moving on to our last question here. What do you feel like needs to change in the industry? And that can be from an employee behavior perspective or a regulatory perspective to adopt the new technologies that you're speaking about. And what would be your advice to our attendees, to stakeholders in the construction sector for adopting these new technologies? And Michael, maybe we'll start with you this time.
Sure. Much like Ray was talking about, just the legacy behavior and just, concrete works, right? Everybody talks about it, the Coliseum, and it's been around forever, right? But we can certainly do better. And, it's an industry of very technical people, and, the technicians that design the concrete today are, generally very advanced and brilliant people, as are the engineers specifying it. So, when you want to introduce something like AI and say, you can do better, what we try and approach it as superpowers for these people, rather than, it's coming here to take your job, right? Everybody thinks of the Terminator when you start talking about artificial intelligence, right? But the fact is as the workforce has evolved, there's also fewer and fewer of those people that can actually do some of this work. And, you don't have people that have been in the concrete industry for 30 years, for the same company anymore. So the ones that we still have around, we should absolutely be empowering with tools to do some of these things. Now, similarly on the specification side, right? There's engineers, and structural engineers are famous for over design, and, we don't want liability and buildings falling down and all that. And so, embracing, the idea of performance specifications, as Kevin mentioned, right? And that, these prescriptive specifications we have in the United States in particular are just archaic. Even if you look north of the border in Canada, it's all about performance and what the end result is that you're trying to achieve. And again, because all of the materials we're using today are vastly different than they were when we started copying and pasting these specifications from 50 years ago, you just need to be open-minded to embracing the new technology. Now, certainly you need to be prudent and test it out and vet things, but to me, it's almost 100% mindset.
Mm-hmm. Yeah, it's a mindset. Yeah. Ray, what are your thoughts?
I would agree with that. I mentioned it earlier that the big gains coming up are going to be in changing the way the sites operate, and the way material moves on the site, and the way energy is consumed on the site. That's really where we're going to get the big gains towards sustainability. We can do the electric machines, we can deploy them, but unless the contractor and the operators are willing to change their duty cycles, change their refueling times, you may be refueling or recharging more often than you're used to. It's not the diesel truck coming in once a day and refueling all the equipment on site. you might be plugging in
Mhm.
20 minutes in the morning, 20 minutes at lunch, 20 minutes in the afternoon, and that'll be your recharge cycle. So it's a totally different mindset that has to go through the industry. The other thing I would mention is of course, and Thomas had made a comment in the comment field that the financial equation for some of these is very, very different than what we're used to with traditional diesel equipment. Like any new technology, there is a premium when it's first introduced. So these machines are more expensive than their diesel counterparts. There's no question about that. But what we're seeing is that the maintenance is much less, the upkeep is much less, the fuel costs obviously are much less. If you can drive on electric instead of diesel, the fuel costs are significantly lower. So we're starting to see that the life cycle costs are significantly lower if you use the machines and do some work with them. If they sit in the backyard and never get an hour on them, of course, you have a very expensive machine to look at all day. But of course, machines aren't made for that. They're made to produce. So we're encouraging operators, yes, they are expensive upfront costs, but put them to work. Make sure you're getting your productivity out of them. And it's the TCO, the hourly costs of running them, is where you're going to have your gains and get your return on investment. And even in the few years that we've been doing this, in the 4 or 5 years, the payback curves on this electric equipment have dropped from 5 or 6 years that they started, and we're now seeing some payback in the 2 to 3 year period. So it's worth the investment, but you've got to structure your operations to take advantage of the unique features and find the jobs where the unique features do good for you. There are many applications where an electric can go indoor tasks around animals, livestock, anywhere where you don't want noise and emissions. These machines can do it where you couldn't use the diesel before. So you're actually replacing people with shovels with a machine to do the job. So there's an advantage to that. And contractors need to take advantage of those opportunities as well when they're deploying these. So
yeah. Okay, thank you, Ray. And last but not least, Kevin, what are some of your parting thoughts?
Yeah, I think one of the key things to do is to be able to measure where you are today. I was meeting with a municipality earlier this week, and one of the discussions we were having was around, there's all these targets in the industry in terms of shooting for CO2 reductions by 2030 or 2050, whatever the metric is that you're using, but establishing a baseline as to where you are today, and then putting the mechanisms in place to be able to track that. And so some of the things that Michael and his group are doing are driving to those reductions. Part of what we're trying to build into what technology of our system is also be able to measure the results of an individual batch of concrete. So we're able to track whether it's a sidewalk or a gutter, or whether it's a bridge or a 12-story building. We can track what that reduction is going to be. I did note there was a question in the stream regarding the use of CarbonCure with the 1L cement. So for those of you who may not be familiar, 1L cement is basically a Portland limestone cement where you're reducing a portion of the clinker with basically unprocessed limestone. So environmentally, it's far more friendly. From our perspective, it's really a dosage situation. So when we're working with that cement, whether it's a 1L or something from just different raw materials, as we're adjusting the dosage based on the individual raw material, and the producer may take more cement out or less cement out depending on what that is. But it's something that we do acknowledge, and there's been a very wide adoption across the US in the last 12 to 18 months. It was a bit of a West Coast thing, as these things tend to be. And now it's really moved across to Texas, where I am today, and Florida. So it is something that we acknowledge that really drives that. But, kind of my parting comment would be is really focusing on, you get what you measure, understand where your baseline is today, what are the most, the steps that bring you the biggest return on investment in terms of your carbon budget, and then measure where you are on that journey, and you'll certainly move forward.
Some great parting words. Thank you so much, Kevin. And thank you to Ray and Michael as well for joining the panel today.